chain rule. It's implicit differentiation. This is outside. Oh, someone let her in. This is, oh, quick. This is inside. What's the derivative of the outside? So it's going to be cosine xy, and let's go ahead and just indicate that we're going to take the derivative of the inside. We're just going to leave it there. What's the derivative of x? 1. And remember, we said we can do dx over dx just to be safe, and what is dx over dx? 1. All right. So now we've got cosine xy, and now we have to do, is there a rule involved? Why is it product rule? What's the rule of thumb? There's two variables, and there's variables on both sides of the equal sign. So we're going to say first times the derivative of the second. Derivative of y is 1, and what did you just do the derivative of? dy over dx, plus the second, which is y, times derivative of the first, which is 1, and you just did the derivative of? With respect to x equals 1. So we've got cosine xy, and these parentheses are important. You cannot drop these parentheses, plus y equals 1. All right, now this is when I'm going to look at the answers. So I can see in the answers that cosine is in the denominator, which means I don't have to make this sign or secant after I divide. So because this is connected by multiply, what's the first thing we're going to do? Divide. So we're going to have x dy over dx plus y is equal to 1 over cosine xy. All right, our goal is to solve for dy over dx. What's the next step? Subtract your y. So you got x dy over dx is equal to 1 over cosine xy what? Minus y. So now I'm going to take a look at my multiple choice answers, and there are no multiple choice answers that have two separate pieces. They're all one fraction. You with me? So now what does that mean I'm going to have to do? We're going to have to get a common denominator, and I'm going to do that now. What is the common denominator? So we've got x dy over dx is equal to, all right, so I'm going to make one big denominator, and it is cosine xy. What did we multiply cosine xy by to get cosine xy? 1. So we multiply the numerator by 1. Minus, what do we multiply this by? So if you multiply the denominator by cosine xy, you must multiply the numerator by cosine xy. So this is going to be minus y cosine xy. All right, so now what are we going to do? You either divide, but since I have a fraction, what am I going to do? I prefer the reciprocal. And then we multiply our denominators times our denominators. We get dy over dx is equal to 1 minus y cosine xy all over x cosine xy. So you definitely will have implicit differentiation in the multiple choice. It is possible that you could have it also in the free response. Okay, next question. Yes?
So number 14?
40?
14.
14. All right, we're doing 14. Same test? Okay. So now we're on multiple choice page 9. We're going to do number 14. It says polynomial function f. Because it's a polynomial function, can someone open the door? Okay, not AP? Okay, so this is number 14. So because they said it's a polynomial function, what do you know about polynomial functions? They are continuous and differentiable. All right, that's a loaded word. All right, not that we need it. Has selected values at its second derivative. What do we know about a second derivative? Concave. It gives the concavity of the original by positive negativeness. It gives points of inflection of the original when the positive negativeness changes. What can it tell me about a first derivative? Increasing, decreasing by its increasing, decreasing. It can tell me that the first derivative is increasing, decreasing by its positive negativeness. All right, that's just stuff we know. Okay. So then it says, which of the following statements must be true? All right, so it says f is increasing on the interval 0 to 2. F is increasing. What do we know that? Does the second derivative tell me anything about increasing of the original? No. F is decreasing on the interval. Does the second derivative tell me anything about decreasing on the original? No. It says f has a local maximum. If it does not tell me about increasing, decreasing on the original, is there any way it can tell me that there's going to be a local max? I'm thinking not. Now, yeah, we have the second derivative test, so I'm going to come back to that one, just in case. D, the graph of f has a point of inflection at x equal 1. We've got 0, 5. We've got 1, 0. We've got 2, negative 7. We don't know what's going on between 0 and 1. We don't know what's going on between 0 and 2. However, that's positive, that's negative, that is a 0. It looks promising. I still think that that might be an issue. It says the graph of f changes concavity on the interval 0 to 2. So here's my interval 0 to 2. Can we say that there's got to be a concavity change somewhere? Yes. We cannot do D. We cannot pinpoint that that's occurring at x equal 1 because we don't know what's going on in between here. The number right next to 1 might have been positive, and on this side it might be positive. But because this is positive and this is negative, somewhere in there it changed concavity, so it must be D. Does that help?
Yeah, because I was confused between D and E.
Yes, and that's why. You don't know what's going on between 0 and 1. We definitely know there's a concavity change on that interval, but we can't say that it's specifically at 1. All right, yes, Brianna. 18 on the same test. All right, so now we're on multiple choice, page 11, number 18. Ooh, in the xy plane, so this tells me xy plane. Oh, there's a desk up there. All right, so we have x plus y equals k. This is number 18 on, again, page MC 11. K is a constant, meaning k is a number. Oh, and this is, the line is tangent. This is a tangent line. And this line is tangent to y equals x squared plus 3x plus 1. What is the value of k? So if I have a curve and I have a tangent line, what do we know about the slope of this line and the derivative of that? They're the same. What is the slope of this line? Oh, good call. We have to move x to the other side, don't we? -1. What is this derivative? 2x plus 3. All right, so we know that -1 has to equal 2x plus 3. So if I move 3 to the other side, I have -4. Let me know when I make mistakes. So x is equal to -2. So I know that half that point is -2. How do I find that y value? Which one, though? This original. Why doesn't this help me? Because I don't know k and I don't know y. So we're putting -2 in. Squared, we get 4. 3 times -2 is -6 plus 1. Do you agree that's -1? Yes, no?
Yes.
All right, so now can I put my -2 in for x, my -1 in for y, and do I have my k? What is my k? -3. All right, did Mr. Southard give you all the answers to the...
No.
So were you able to get them from my class? Because I did post them on my portal. Okay, so the question is, how do we get them? If you will give me an email, I will email them to you, okay? Because I don't think I need to make that public, because one of them is 2012 test, and I'm not supposed to do that. Okay, but I can do it. So you're going to need a sheet of paper, yeah, put your email. Anybody else who is not mine that wants those, this paper can go around. All right, I can do this better now. Yes, sir. In the back, JP. Yep, we're on another question. Multiple choice 56. Multiple choice 56. That's a free response, isn't it? Oh, I probably should see that. Okay. So, we've got, do you mind if I do the whole thing? Okay. We have raw sewage. Okay. It says the word rate, the rate at which raw sewage enters. All right. This is multiple choice page 56, number 1, free response. So we have a rate, and it's an enter rate. And that rate happens to be E of t is equal to, oh, by the way, this is a graphing calculator. I tried using my graphing calculator on the smartboard and it didn't work, 7th period. So I might not be able to use a graphing calculator. Did you all bring yours? Okay, so that's the enter rate. And what's the big deal right now on the AP exam is when they give you rate problems and you should have a rate problem. Where's number 6?
I couldn't do it because we went over it in class.
Oh, okay. Can you, I need a pencil or pen so I can record it because I don't have my grade book with me.
Okay.
All right. Oh, perfect. Okay. So this is the rate where the sewage is entering. What's happening? It says, and that's gallons per hour. We want to make sure we know about our units. Then it says on the interval 0 to 4. All right, so I don't know how much Mr. Southard went into this, but when I see a closed interval 0 to 4, I'm thinking mean value theorem, intermediate value theorem, and extreme value theorem. Those are things I want to bring to the forefront of my head. It might happen. Now it says treated sewage is removed, and it says, oh, we need, wait, hurry before he leaves. Hurry, open. Okay. So it says treated sewage leaves. We're on multiple choice page 56, number 1. So now we're removing. And that's got to be another, and it says from the tank at a constant rate. So I'm going to call that R of T for removal at a constant rate of 645 gallons per hour. And I think that one of the things that I think makes this more difficult is whenever they give me a constant rate, they usually don't do an R of t or a V of t or any type of function notation. So that's an easy piece of information to lose. The treatment tank is empty. So in the beginning, this is an initial value. This is important. There is 0 gallons at t equals 0. All right, and these initial conditions I used to always forget. All right, always. So that's just FYI, my experience. All right, part A. Part A is asking how many gallons of sewage. So they're asking for gallons. That should tell you something. Everything here is in gallons per hour. How do I go from gallons per hour to gallon? Integrate. All right. So that means I'm going to integrate, and what am I going to integrate? It says enters the treatment tank. So am I using the R or the E? So I'm going to do E of t. This is a calculator problem. You can use E of t because they have named it E of t. During the time interval 0 to 4, and that's dt. And I will try again to see if I can get the calculator, but it wouldn't work. Oh, you mean Dia? Yeah. Oh my gosh. This is a good day. All right. So I'll give you some calculator tips as we go. So here we go. I've got to find my notes. So we're going to come in over here, maybe. All right, and we're going to go to y equals, and we're going to enter, oh, by the way, is your calculator in radian mode? All right, I can't see this far away. Someone's going to have to read this to me so that I make sure I type it right. So it's 850 what? Plus 715 cosine pi. Is it t squared or the pi and the t? Okay, now you know that's a variable, even though it looks like an x, that means variable. So variable squared. The pi, x squared over 9? Okay, so I'm safe because order of operations says multiply, divide. And if we're good there. If it was addition, I would have needed parentheses. Is that it? Okay, and what did they tell us we're looking at? What's my interval? 0 to 4. So that means that I'm going to come to my window, and I'm going to set my window from 0 to 4, because you only want to look at what they've given us. Okay? You only want to look at you don't want to look at any extraneous stuff. And from what I can see, I can't see a thing. But am I at least 0 to 4? So we're going to now do second trace. We're going to choose 7, and I'm going to integrate from 0, that's my low limit, enter, to 4. And I get 3,981. And what did they ask us to do? Round to the nearest gallon. So what would that be? 3,000, what? 981 gallons. All right. So what did they ask us for? They said, how many gallons of sewage enter the treatment tank? And it says, round your answer to the nearest gallon. So we're going to say is equal to, I don't have a pen, is equal to 3,981 gallons. All right. Yes. Yeah. Well, is it approximate? Oh, yes, because I rounded. Thank you. One year they did. They haven't since I've been grading. Okay? But you never know. So it's always safe to be on the safe side to do that. Okay, for those of you who just entered, we're on page 56 of multiple choice number 1. Come on up. All right, then we're going to go to part B. 50 cosine pi x squared divided by 9. I don't think so.
What's the rating
Node. Oh, that's it. There you go. Now. Hold that. Okay. All right. So part B, it says for 0 to 4. All right. Look at the 0 to 4. What kind of 0 to 4 is it? Closed interval. What should we be thinking? Could be EVT, MVT, or IVT. It might not be, but we should be prepared. It says, what time is the amount of sewage? Okay, now, when we talk about the amount of sewage, did they say enter? Did they say exit? So if we're talking about the amount of sewage, what are we dealing with? All of it. So that means enter minus what? Exit. And that would be notice how I named my 645. So because I named my 645 in my work, I can say E of t minus R of t. If you did not name your 645, you'd say E of t minus what? 645. Mm-hmm. My R of t, it's at the top. They would look for that. They would look for that. All right, so anyway, so we're dealing with that. So now they want to know, when is it the greatest? So what do we have? We have a closed interval. We have greatest. What is that? Extreme value theorem. So when you've got this extreme, they want to know so they want to know, first of all, time. And then the second question is, to the nearest gallon, what's the maximum amount of sewage in the tank? So let's go back to our calculators. And this time, did I already graph this from 0 to 4? Oh, good, thank you. So that's E of t, right? And then this is going to be minus 645. All right, so what do we have? We have two, well, they're not asymptotes, they're actually part of the graph. What we can do is I can go to my maximum y's, and what if we made it 500? I think I might need to make that maybe negative 100, because I still need to see my y-axis. What's going on? Okay. This is a derivative. If the derivative is positive, then it goes negative. What do I have? Positive to negative. Maximum. When it goes from negative to positive, what is it? Minimum. So what we're going to do is we're going to do second trace. We're going to go for the 0. We need to find these points. So the first thing they ask us is they want a point on the left. Hit enter. They want a point on the right. And that is to the right. Hit enter. And I'm going to hit enter one more time. What are we going to do with this number? So we're going, for those of you, maybe you don't know how to do this, we're going to do second, what is that? Quit. We're going to hit the store button, which is next to 1. And we're going to store this in, maybe, we're going to store this in alpha A. So now we're going to tell the AP people that A is equal to 2.309342842 in case we need to use it, which we are going to use it in a minute. So I'm going to go ahead and do second, I'm going to go to second trace. I'm going to choose 2 again because now I want to find that point. And that's got to be, so I'm going to, instead of moving my cursor, I'm going to choose 3 on the left. Because notice 3 is to the left, and I'm going to choose 4 to the right. I know 4 is the farthest to the right I went. So I've got 4. I'm going to hit enter. And this point, I'm going to label this B. And before I label this B and forget, I'm going to do second, quit, and I'm going to store that in alpha B. Alpha B. Okay, we need the door opened. Okay, so, and then we're going to write down that B is 3.559063871. Okay? So, let's go back to our graph. What did we already say? They wanted the greatest. What does greatest mean? Maximum. So which one are we not going to consider? We're not going to consider the B because that's going from negative to positive. So now when we have extreme value theorem, what do we have to consider? The endpoint, so we're going to do 0 plus the integral from 0 to 0 of my E of t minus my R of t, which was 645 dt. And what is that going to be? 0. Okay, I'm emphasizing the fact that I have 0 plus, because if it weren't 0, we would have had, let's say there were 10 gallons of sewage to start with, it would be 10 plus. Yes? 1. Yes. This was a calculator question. So you don't have to show the work of the integration. What you do have to do is you have to show the integral. Yes. So now we're going to do 0 plus the integral from 0 to a, because remember we said that was possibly a maximum. This is at least a relative minimum, so we're not going to do anything with that. So now we're going to do E of t minus R of t dt. And what are we going to do? We're going to go to our calculators. We're going to turn them on. Yours are already on. Mine never stays on. So we're going to turn it on, and we're going to do second. We're going to do trace. We're going to choose 7. Did Mr. Southard show you how to do 7? Okay, so you're going to choose 7, and we're going to go from 0 to what? See, you don't have to type that number. You would have had to type all those digits in, or you have a rounding error. So we're going to do alpha maybe. There we go. Oh, wait a minute. Maybe I don't want to do alpha. That was my lower limit. We're going to do enter. And now we're going to do alpha A for my upper limit. And did they tell us to round to the nearest gallon? Yes, they did. That's 1637, I think. Yep. So we're going to do 1637. I need you to go away. So this is equal to 1637. Then what are we going to do? 0 plus the integral from 0 to 4. We're not going to do b because that's a relative min. That saves us time. We've got e of t minus r of t dt. So when it's absolute extrema, you've got to consider both the endpoints and the critical numbers. So now we're going to do second trace. Do I have my e of t minus? Am I using the right function? Okay. So now we're going to choose 7. And we're going to go from 0 to 4. Why should this be lower? Because there's negative. That's 14.01. So this is going to be 14.01. So what do we say? They wanted time. At t equal 2.309 hours. Well, remember they want the time. Then you could say at A. Yes, you could. So notice I have my rounding. Don't give them 2.3. Don't give them 2.30. You have to do 2.309. At 2.309 hours, the maximum amount of sewage, and I'm going to abbreviate, you won't, is, now wait a minute, oh yeah, you could have said at t equal A. Zach, I'm with you now. I'm a little bit slow on the uptake. The maximum amount of sewage is 1637 gallons. Okay, that was part B. Is that what you needed, Zach? C. So, yes. Do I have to justify? Oh, justify your answers. Oh, by, what's the justification? EVT. That's the extreme value theorem. What, if you're not sure of which theorem, what do you say? Because the function is, because E of t minus R of t is continuous. Even though they didn't tell us that, they should have told us that. So they didn't write a very good question, but they will on the exam. All right? When in doubt on a theorem, say because the E of v, whatever function they have is continuous. They will accept that. Part C, again, we have a closed interval. So that concerns me. What am I thinking? Could be one of those theorems again. The cost of treating the sewage. Oh, I'm so glad you asked this. The cost of treating the sewage that enters the tank at time t, I'm going to say C of t. Notice I'm defining this. They didn't name it, did they? I'm naming it. 0.02 t. There's its name. That's the cost. And that is dollars per what? Gallon. To the nearest dollar, what are they asking us? For dollars. What does that mean we have to ditch? Gallons have to disappear. All right. To the nearest dollar, what is the total cost of treating all the sewage that enters the tank? Am I going to be dealing with E alone, R alone, or them together? E of alone, all right? It's what enters. So if I were, in order to get to dollars, am I going to do a derivative or an integral? If I'm in a rate and I need dollars, I'm going to need to integrate. So if I were to just integrate my C of t dt, all right, this is how we play with units. If in doubt, play with units. C of t, they told us, was dollars per gallon. What's dt? Time. What is our time? Hours. Does dollars per gallon times hour give me dollars? No, that means that is not acceptable. So, what do you think we need to multiply the cost by? E of t. Let's check it out. dt. Now, what are the units on E of t? It's gallons per. So this is gallons per hour. And now what's d? Oh, that's an h. That's hour. What is dt? Hours. What's going to happen? Gallons are gone. Hours are gone. Will this truly give me dollars? Yes. When in doubt, play with units. That has helped me understand a problem when I wasn't sure if I was right or not. So they want from 0 to 4. So what are we going to have to do? We're going to have to go back to our calculators, and I'm going to turn mine on. I think I'm going to come down here. What did we say? Delete, delete. Is that my E function? Okay, I'm going to close it off because my E function is not in parentheses. I'm going to insert second. I want to insert. I don't think I've, there we go. Insert. I'm going to insert a parenthesis. So my E is in parentheses. So now what am I going to multiply this by? C, which is parenthesis, 0.15. Bless you. And that 0.15 is minus 0.02 times my variable. Close the parenthesis. What are we integrating from? So we're going to do 0 to 4. And how much is this going to cost? Did they say round to the nearest dollar? It's going to be approximately $474. Does that help? Okay, next question. Yes, ma'am. 22 multiple choice. Is this? I'm here for you. We're going to do whatever you want to do. 82 on what page? Because there's 3 multiple choice tests. Okay, so we're on page multiple choice 49. We're doing 82. All right, so new page. So 82 says f is continuous. 82. All right, just the fact that it says continuous means we might be in theorems. Then we see the comment closed interval. You put continuity and a closed interval together, what are you thinking? You're thinking IVT, intermediate value theorem, EVT, which is extreme value theorem, MVT, which is mean value theorem. Now it says, which of the following must be true? They've only given us continuity. What is missing? There is no differentiable. No mention of differentiability. All right? All of these require continuity. There's only one that requires differentiable. Which one is it? MVT. So if they did not tell us no mention of differentiability, we take that off the table. So it's you're either looking for intermediate value theorem or you're looking for extreme value theorem. So part A says, just because a function is continuous, they're saying f of c, which means the y value, there is a y value somewhere on this continuous graph where y is 0. Is there any guarantee if the function is continuous? If in doubt, can I draw a graph that is continuous without having a y value of 0? Yes. So is that true? That's a maybe, but isn't it always? No. Part B, again, is talking about, now they're saying the y value at A is smaller than the y value at C, which is smaller than the y value at B. So in order for this to happen, do you agree you have to be increasing? This y is smaller than that y, which is smaller than that y. Just because a function is continuous, does it mean increasing? No. So that's not going to be helpful. Part C. Now they're saying the y value at C is bigger than or equal to every other y value in that interval. Is that extreme value theorem? Does it bother you with the equal to? It used to bother me, but this is why they put it. If you have a horizontal line, and this is A, and this is B, and this is your C, do you agree that that C is equal to at least every other C? So that is one of those like special cases where it's at least, so I'm really thinking it's C, but I'm not going to put C until I look at what? The other choices. There's a number C. Now, this says the derivative equals 0. Oh, that should be a C. What did we say? No mention of differentiability. Should we even consider D? There might be a sharp turn. Correct? Can you be, this is a continuous function, but is it differentiable here? No. So that does not mean that there's guaranteed to be a 0. Look at E. What is E? That is a theorem. It is MVT. And what did we say about MVT? Can't be considered because they did not give us differentiable. So what is the answer? C. Okay, next question you want C. Yes. Okay, we're on MC33, page 10. Number 10 on MC33. All right. You have a graph, and in this graph, you have a horizontal asymptote and a vertical asymptote. Question, where is the horizontal asymptote occurring? At y equals 3. Where's the vertical asymptote occurring? At x equal 2. So the function is given by f of x is equal to ax squared plus 12 over x squared plus b. The figure above shows a portion. Which of the following could be the values of a and b? How do you find vertical asymptotes? Set the denominator equal to 0. X squared plus b equals 0. Do we know where this is occurring? So what are we going to put in for x? So that's going to be 4 plus b equals 0, or what does b equal? Negative 4. All right? At that point, how many negative 4s are there? Just one, but let's finish it. So now how do you find a horizontal asymptote? There's a shortcut, and then there's calculus way. We really need to know the calculus way in case they test that later on. You won't be able to use a shortcut. Limit to infinity. So if I do the limit of ax squared plus 12 over x squared plus b as x approaches infinity, this is supposed to be 3. How do we do this when we have polynomials? Exponent of x in the denominator. So it's 1 over x squared. This is going to be 1 over x squared. So we're going to have limit. Do you agree that will be a plus 12 over x squared? And then that's going to be 1 plus 1 over x squared as x approaches infinity. Now, when this denominator gets incredibly large, what's the overall value of the fraction? We have a whole pizza. I eat the pizza. I'm miserable. I share it with Christina. We are probably full to the max. We share it with the girls on the front row. We are all pretty well full. Now we're going to share this pizza with the entire school. How much of a piece of pizza are you going to get? A crumb at most, if you could see that crumb. So as this denominator gets incredibly large, the overall value of the fraction is going to 0. So we've got a plus 0 over 1 plus 0. What did we say it was equal to? What is a? Yep. So that was D. Yes? We can take x to negative infinity. It had to do with the roots. But let's talk about negative infinity. What if you have e to the x, and we want to do the limit as x approaches infinity? What is that going to be? Infinity does not, what? Exist. All right, so now let's do the limit of e of x as x approaches negative infinity. What does that mean this x is? This x is what? It's negative. It's very, very, very negative. What does a negative exponent do? It makes it 1 over. So this would be the same thing as 1 over e to the x as x goes to positive infinity, right? And now what's happening? This is getting incredibly large, which means the overall fraction is getting incredibly small. All because negative infinity means that's a negative exponent. Negative exponents mean it goes down in the denominator. So then all of a sudden there's a limit when there wasn't a limit. Yes? Uh-huh. Where did the b, which? Oh, the b, that's going to be, oh, that b is right there. But it's a number, so it's still going to 0. Yes, sir. 70, number 28. 17, number 28. Uh-huh. Say it again. Limits to infinity or horizontal asymptotes, denominator equals 0. No limits involved for vertical. Well, I lied. If you have a vertical asymptote, let's say this asymptote is at 3, and I'm approaching 3 from the left. If I have the limit of a function that approaches 3 from the left, and it is, the answer is infinity, that is, notice, number, answer is infinity, that indicates a vertical asymptote. All right, so we're on page 17. That's a multiple choice, and we are doing number 28. Oh, I like this one. Okay. F is differentiable. That means it's continuous and the derivative exists. So they're giving me, what I see is I see g of x is the what? What is that notation? Inverse. So as soon as I see inverse, I spent a whole week in this AP Summer Institute, and this, I learned absolutely nothing new, and this person that did it showed me this table, and it was worth 40 hours of sitting there. All right, so this is the deal. This is x, this is y, and this is the derivative. Mr. Southard should have taught it this way, because I taught him to teach it this way. So this is f, and this is g. So I think maybe I might have to do several lines. They told us when f is 3, what is the y? 15. What does that mean about g? When g is 15, y is 3. What else did they tell us? They told us when f is 6, the y value is 3. What does that tell us? G is 3, y is 6. All right. Now they're going to tell us that the derivative at 3 is negative 8. The derivative of f at 6 is negative 2. So what does that mean this derivative is? Negative 1/8. And what is this derivative? Negative 1/2. All right, so they say the function g is differentiable. They want the derivative now. They want the derivative of g at 3. Well, there's 3 in g, and its derivative is what? Negative 1/2. That table's amazing. Absolutely amazing. So did they give you a bunch of stuff to confuse you? Yes. Because a lot of kids are going to pick up, if they said g prime of 3, they're going to look at the f of 3, and they're going to give you negative 1/8. And they had it there, by the way. Okay. Julie. Say that again. Okay, so your table, you're going to have an x column, a y column, an f column, and this is your inverse. That's f inverse. because they said G was the inverse, and then you have a derivative column. And depending on what, they could have given you a G. If they gave you G to be 15, you know that's an Fy. And that's what we did in the homework. They gave us G to be 15. We put 15 in for Y. We set the F function equal to 15, got our X. We had to go through a lot more work. This is more AP style. Ariel. Page 47, number 79. Oh, that sounds like a related rate to me. So this is multiple choice, page 47, number 79. A spherical tank contains 81.637 gallons of water. Maybe not. At t equals 0. What does that mean? That's your initial condition. Okay. For the next 6 minutes, water's flowing out of the tank. So I'm going to call this O of t for what? Out. O of t is equal to 9. And this is going to be sine square root of t plus 1. And that's gallons per what? Gallons per minute. It says how many gallons of water. So the question is gallons. So if I'm given a function that is gallons per minute and I want gallons, what calculus am I using? Integration. So I'm going to be integrating my O of t function, which is 9. By the way, this is in the calculator portion. Sine t plus 1, and that's square rooted, dt, you're welcome, at the end of 6 minutes. So we're going to go 0 to 6. Now, what is this water doing? Is it coming in or going out? It's going out. But that is only going to tell me, that integral right there will only tell me how many is going out. I want to know how much is in the tank. What do you have to do? Take your initial condition, which is 81637, and subtract that integral. And I'm going to let you do that on your calculators. Yes? So we're going to back a page to number 77. All right, so let's look to see. This is now multiple choice, page 46, number 77. We've got the integral from 0 to 3 of f of x dx, and that is 6. We've got the integral from 3 to 5 of f of x dx, and that is 4. They're testing your limit properties. They're telling us that the integral from 0 to 5 of 3 plus 2f of x equals what? That's an x, that's not a t. All right, so they're testing your limit theorems. So what's one thing we can do since it's addition? Separate it over the addition, correct? So now that's going to be plus the integral from 0 to 5 of 2f of x dx. All right, how do you integrate 3 with respect to x? It's going to be 3x, and that's 0 to 5. All right. Now, what can we do with this 2? We can bring it to the outside, and we really need to do that to figure out what this one is. This one we can compute, not an issue. This one requires the information above. 0 to 5, 0 to 3 is 6, 3 to 5 is 4. What is it from 0 to 5? So this is going to be 3 times 15 minus 0, and this is going to be plus 2 times, and we're going to say 4 plus 6. So that's going to be 45 plus, okay, so that's times 5. I'm going to say this is not the answer I got in class. So now this is going to be 15 plus 20, which is 35, and that was the answer. Yes, Morgan. 51, number 85. So 51, number 85. All right, so I looked at this. And I'm looking at those pictures, and to be honest with you, the picture on the left made it look really, really hard. Okay? We don't even need the picture on the left. What we've got is we've got this picture, and what is it doing? We've got a little bit here, and we've got a lot here, and then we're going to go from here up and from here down. And what did they tell us? Oh my gosh, they even told us that y equals x squared over 10. So they're saying the base of a loudspeaker is determined by the two curves, from 1 to 4. The loudspeaker cross sections perpendicular to the x-axis. That means that, and I don't know, did you all do Play-Doh in Mr. Southard's classroom? Okay. So if we put Play-Doh here, and I take an index card and I stick it in the Play-Doh, it leaves that line if I pull it out. Does that make sense? All right. These cross sections are squares. So what I did is I took my square, and this part of my square was in the Play-Doh. Okay? So I've removed my square. The question is, I need to know how long this is. And whenever we have a function, what do we always do? Top minus bottom. By the way, I think that's a negative. Okay. So we're going to do x squared over 10 minus a negative x squared over 10, which is what? What is that? 2x squared over 10, what is this? 2/10 x squared, what does that reduce to? I guess we don't need to do it, it's a calculator portion. So, what's the area for a square? It's going to be 2/10 x squared what? Squared, and what are we integrating from? 1 to 4. Why don't I put a pi out front? It's a square, not a volume of revolution. So that now you have to do in your calculator. You could reduce that to 1/5, but since it's calculator, if you don't want to make that mistake, I don't remember the answer to this one, but I can tell you this is 85. It was D. It should have been 8.184. The next page, 86. Function f is continuous and differentiable. Keywords. Continuous and differentiable means and a closed interval. So I see the word continuous, I see differentiable, I see a closed interval. What should I be thinking? EBT, IBT, and NBT. The table above gives selective values of f. So the next thing I want to notice is that this is an original function, is not a derivative table or a second derivative table. Which of the following statements must be true? Don't you just love this? All right. So minimum value, that would be EVT. Again, we've got 3, 4, 5, 6, 7. We've got 20, 17. Do you agree that 12 is the smallest number on what they've given us? But are we guaranteed that that is the smallest? Is it possible between 4 and 5 we got lower than 12? Or on 5 to 6 we got lower than 12? We don't know what's going on there, so we cannot say that that is true. Part 2, there exists a C. Now they're saying f prime of C equals 0. I'm into a derivative. It is differentiable. I'm thinking mean value theorem. What is mean value theorem? Slope of the secant is equal to slope of the tangent. Slope of the tangent is your derivative. Slope of the secant is your algebra 1 slope. Looking at the data table, is there any way you could do algebra 1 slope and get 0? Yes, where? If we used this ordered pair and this ordered pair, what makes it special? The y's are the same. When you subtract the y's in algebra 1 slope, will you get 0? So definitely 2, and that's mean value theorem. And the next one, they're saying that the first derivative of x is greater than 0. If you have a first derivative greater than 0, what does that mean? F is what? Increasing. So they're saying that from 5 to 7, the function is increasing. It looks like it's increasing, but do we know what's going on here and here? It is possible the function went down and back up. So this is not an absolute. So the only one is 2, and that was B. Catherine? Okay. That's an excellent question, and I think that is definitely should be done. So we've got intermediate value theorem, we've got extreme value theorem, and we've got mean value theorem. All right. All of them require continuity. Function must be continuous. So if you see something and it's not continuous, and they say, why is there not an absolute extrema? It's because it fails the if part. We also know that on MVT, that you also must have differentiable. If it does not tell you that something's differentiable, you cannot use MVT. So intermediate value theorem says that if, okay, then there has to be a y in between A and B such that. So we would do continuous on the closed interval. Then we would show that f of A is less than f of C, which is less than f of B, because we had a closed interval here, A, B. Okay? And if that was true, then that means that there is a x value C such that the y value is 5. Let's go up to this table. Let me try to give you an illustration. The question is there a time, is there a value C when f of C equals 18? So, did they tell us this function was continuous? Yes. So, if you recall, we would say yes on the interval 3 to 4 because 20 is greater than 18, which is greater than 17. And then we say by intermediate value theorem. Mm-hmm. No. But they would only give you one that worked. Okay? So that's what we mean by intermediate value theorem. Extreme value theorem means that there are absolute minimum and there's an absolute maximum. And those absolute minimums and the maximums occur at the endpoints, that would be the A and the B, or at a critical number. There's a lot of justification on this one. You have to show the y value at the endpoints, each endpoint, and the y value at each critical number to use this. Mean value theorem is going to say that the slope of the secant line is equal to the slope of the tangent line. Slope of secant line is algebra 1 slope. Slope of the tangent line is your derivative. So they're saying that algebra 1 slope equals the derivative. Yes? Fundamental theorem of calculus, yes. There's a couple of them. There's a fundamental theorem calculus 1 and there's a fundamental theorem calculus of 2. If we, let's see, f of x is equal to the integral from a to b of, let's say, f of t dt. Fundamental theorem of calculus says, I think the first one, that equals f of b minus f of a. You will see this, you will use this a lot in the free response on tables or in the multiple choice. You should be on the lookout for this in a table. Let me come up here and give you an example. They may ask you to integrate from 3 to 4. We'll call this f. F of x. So that would mean that it would be capital F of x from 3 to 4, which means, I believe, so this is the derivative. This is the derivative. So and this is table f of x, then I would do f of 4 minus f of 3, and f of 4 is 17 minus 3 is 20 is negative 3. Okay, when you have a table on a free response, or if you have a table in the multiple choice, it's a possibility. They will test you somewhere on that concept. It is a big one. All right, then I think the other one had to do with, if I have, let's see, that the derivative of f of x. Let's do the integral. The derivative of an integral of some number to some function of, let's say, g of t dt says that you take the, first of all, that has to be a number. Then you'll do the derivative of the upper limit times that function substituted into your function. That will be tested somewhere. Yes. Yes. And I will even go through and give you, let's go through the possibilities, okay? And then I'll go through and I will pick some from the tests. So, definition of derivative. We gave you 4 definitions of derivative. We gave you the limit of f of x plus h minus f of x all over h as h approaches 0. Now, this is the same thing, limit of f of c plus h minus f of c all over h, this should be x, approaches 0, as x approaches 0. These are the same thing. This is the derivative at x equals c. Then we gave you another one, limit of f of x minus f of x minus h all over h as x approaches 0. This is the same thing as the limit of f of c minus f of c minus h all over h as x approaches 0. So, oh, there should be h approaches 0. I was right the first time. Sorry about that. Because we want h to get smaller and smaller and smaller. All right, so on this one, this again is the derivative at x equals c. Then we gave you the limit of f of x plus h minus f of x minus h all over 2h as h approaches 0. This would look like the limit of f of c plus h minus f of c minus h all over h as h approaches 0. And again, this is the derivative at x equals c. This is just the main derivative. Then the last one that you got was the limit of f of x minus f of c all over x minus c as x approaches c. And again, this is the derivative at x equals c. All right, so I am looking on our first test in here. And I want you to turn to page, seriously, it's got to be in here. Yeah, I'm looking to see if it's on this first one. That one is not. Huh. All right. So we're going to go to page 35, MC 35. It's definitely in the next one also. All right. So if we look at MC 35, the key here is that you are able to choose the correct function. So this is number 14 on MC 35. You've got the limit as h approaches 0 of e to the 2 plus h minus e squared all over h. So, and it just says equal. This is saying take derivative of some function at x equal 2. All right? So, trying to do this limit, no way. You have to recognize the function. What is my function? E to the x. This whole thing gets replaced with x. That is e to the x. So, what is the derivative? How do we do? This is good review. How do we do the derivative of an exponential function? ln of the base times the function as it appears times the derivative of the exponent. So this derivative is just e to the x. Now, what am I supposed to do? F prime of 2 is going to be e squared. Don't assume that it's always going to be this one. E to the x is special. It's the only function that is also, its y value is also its derivative. All right, so now we're going to go to 2012. We're going to go to the next exam. And this question was MC 71, number 18. Yes. Because they're asking you specifically, this whole thing right here, this right here is saying take the limit of a function at x equal 2. Let's come up here. Do you see that x? It got replaced with c. It's the derivative at x equals c. So when we come down here, that x is 2. Okay? Are you there? Are you on MC 71, number 18? All right. So this one says limit of ln of 4 plus h minus ln 4 all over h as h approaches 0. That's saying take the derivative of some function at some value of x. What's the function? The function is ln x. And what are we taking the derivative at? X equal 4. All right. So what is the derivative of f? How do you do the derivative of ln? 1 over the function times the derivative of the function. So now what is the derivative at 4? Remember to change a base if it's an log. What is this derivative? 1/4. So I brought another multiple choice test. This is either 14 or 15, and let me find it here. Is it safe to say that you need to know how to do this? Here are 3 multiple choice tests that are more current, because 2008 was what, 8 years ago? Long time ago. Expect it. Look for it. So now we've got limit. For those of you who are listening, you do not have this in your book. Minus ln of 5 all over x minus 2. Now, is this a different form? Is this a different form? There are no h's, are there? It's x minus 2. Which form is it? The last one. So let me go back. And if you notice on the last one, if you need the function, it is right there. It is staring you in the face. It is screaming at you. All right? So what is my function? It is ln x plus 3. So f of x equals ln of x plus 3. And we're doing the derivative where? At x equals 2. Right? Because what happens if you put 2 in here? What do you get? ln 5. All right, in case you don't believe me, let's go back. This is the derivative as x equals c, and that's f of c. It's not saying this is c. This is saying it's f of c. This is your c. And is it approaching 2? Yes. So how do you do the derivative of a natural log? 1 over the function times the derivative of the function. So now we're going to do the derivative at, oh, that's a 2. So that's going to be 1 over 2 plus 3, or 1/5. It's on the exam. I'm telling you now. And they can ask it in so many different ways. Wait, let's go to Mocha. A what? A beast. Yes, I will get there. Okay, let's do a beast. We're going to go to multiple choice. No, we're going to go to the M section of the free response. The beasts on the AP exam are going to look more like, let's see. Like possibly 11, 12, 13. Oh, let's do, this is M13. Okay? Let's do M13. Bye, ladies. I'm here tomorrow. Let's do number 13. So this is what I'm going to do. I'm going to pause, and I want to give you an opportunity to do it first.